morning to all of you. I am Dr. Tanish Chaudhary. I am Assistant Professor, Dharampet M. Dev Memorial Science College, Nagpur. And today we are going to conduct a practical of Bsc Sem 3 Organic Chemistry. Okay? Now, the aim of our experiment is to identify the given organic compound. Okay? The given organic unknown organic compound. Now, the requirements are test tube holder, spatula, then china dish, burner, Hillis tube, then sample compound, litmus paper, aniline, sodium hydroxide solution, etc. Okay. Now about the procedure. So procedure involves 5 different steps. First is the preliminary test. Okay. Here about the color. So just we are observing here that the color of this organic compound is white. Okay, so it is white solid. Now about the nature. So it is crystalline in nature. Then about odor. So if I am smelling it, it seems odorless. Okay, so our given compound is odorless. Then action of heat. So when we burn it, it burns with sooty flame. Sooty flame indicates the presence of aromaticity in the compound. That our given organic compound is aromatic in nature. Okay? And solubility. So this organic compound is soluble in hot water only. Okay? This was all about the preliminary test. Now second, detection of extra elements. Okay? So our extra elements are sodium, our extra elements are nitrogen, sulfur and halogens. Okay? So our extra elements are here nitrogen, sulfur and halogens. And how we detect these extra elements? With the help of sodium extract preparation. Okay? Now, just in short we will discuss how we will prepare our sodium extract. We take sodium metal pieces, then our pinch of compound infusion tube, then we heat it till it becomes red hot, and then we plunge it in distilled water, okay, which is already taken in a china dish. Then we have to boil the china dish for 10 minutes, then we have to cool it and filter it. Okay. The filtrate what we will get is our sodium extract. So with the help of the sodium extract, we will detect the extra elements. Here actually the role of the sodium metal is that as it is very active metal, so it converts our organic compound into inorganic ionic substances, okay, which makes our detection easier. Now, if the sodium, if nitrogen is present, then it gets converted into sodium cyanide. Sulfur is present as an extra element, then with sodium metal it gets converted into sodium sulfide, and halogen gets converted into sodium halides. Now about the test. Okay? So here first we will perform the test of nitrogen. For this test what we have to do? Take 2 ml of Se, that is our sodium extract, 1 ml of freshly prepared ferrous sulfate solution. Then what we are going to observe, that a green PPT is formed. Okay? This green PPT indicates that nitrogen is present here. Okay? In this organic compound, nitrogen is present. Now again further, we add dilute H2SO4 in this green PPT till this PPT dissolves. And then we have to boil it. Okay? So what will happen? Again we will get a Persian blue color PPT. Okay? Green and Persian blue color PPT, whatever. So our nitrogen is confirmed. Okay? So one of the extra element gets confirmed. Now after testing we found here that sulfur is absent and also halogens are absent. Okay? So only one extra element, that is nitrogen, is present in our organic compound. Now we move towards our third litmus paper turns blue, this infers that amide group is confirmed here. Okay, that is CONH2 group, amide group is confirmed here. Okay, so till now what we have observed here, that from sooty flame compound is our aromatic, and here amide group gets confirmed. So we can infer that our compound may be benzamide. Okay. So now we will proceed towards the confirmatory test of benzamide. So here now how we will do the confirmatory test. Take 0.5 grams of our substance. In it add 5 ml of sodium hydroxide solution. We have to boil it and cool it. Okay. So what we are going to observe? White PPT. Okay. And again the red litmus turns blue. This infers that benzamide is confirmed here. Okay. Now this is the structure of our benzamide. This is the aromatic ring and the amide group is connected to this ring. Okay. So benzamide is confirmed here. After the melting point determination with the help of Thiele's tube, its melting point further confirms the benzamide, that is, it is around 128 degree centigrade. Okay. Now again we are going to do a special test of benzamide. For this special test, take a pinch of compound. In it add 1 ml of aniline and then heat it. So again what we are observing here, the typical pungent smell of ammonia, white PPT here formed. Okay. So here it infers benzamide confirmation. Okay. So benzamide is confirmed here. Now about the derivative preparation of this our organic compound. So how we are going to prepare our derivative? We are going to prepare the benzoic acid. Okay. The derivative of benzamide is benzoic acid. For this preparation, take 1 spatula of our compound. In it add 10 ml of sodium hydroxide solution. We have to boil it and then add dilute HCl, that is the hydrochloric acid. So here what we will observe, white PPT. This white PPT shows the formation of benzoic acid, okay, which is a derivative of our organic compound benzamide. Now again the melting point determination further confirms the benzoic acid preparation. Its melting point is found to be 122 degree centigrade, and this is the structure of our benzoic acid. So today we have successfully identified our given organic compound, that is the benzamide. Now on table we are going to perform all the experiments related to this tractor. Okay. So now we will test the action of heat on our organic compound. This is our unknown organic compound. Okay. And here we see what is the action of heat on this organic compound. So here we see that this organic compound, it burns with a sooty flame. This sooty flame confirms that our given organic compound is aromatic in nature. Okay? Aromaticity is present in our organic compound. Okay? Now we are going to check the solubility of our organic compound. For this, take pinch of our organic compound in a test tube and add in it this cold water at room temperature. So here it is not soluble in cold water. Now we are going to heat it. Yes, after heating we are observing that our given organic compound it's getting dissolved, okay? And we are getting a crystal clear solution. Okay? So our organic compound gets dissolved in hot water only.
Okay.
Now we are going to detect the extra elements present in our organic compound. So for that we have to prepare the soda extract. Now we are going to see here how to prepare the sodium extract. Okay. For this, take this fusion tube. In this fusion tube, add some sodium metal pieces. The sodium metal pieces, they are dipped in kerosene as they are very active. So take the sodium metal pieces and first we have to dry them with the help of filter paper. And then put it inside this fusion tube. Okay. Now inside it add our this unknown organic compound. So our fusion tube consists of sodium metal as well as our organic compound. Okay. Now we have to heat it till it becomes red hot. So now we have to heat this fusion tube till it becomes red hot. So till it becomes red hot. Yes. Now we are going to detect our first element, that is the nitrogen, from our soda extract. For the nitrogen test, we have to take 2 ml of our sodium extract. Okay. So this is our sodium extract solution. This is our freshly prepared parasulfate solution, and I am going to add it. If we add dilute H2SO4 in it, this green PPT will dissolve. This Persian blue color PPT, this confirms the presence of nitrogen. Test of sulfur is absent and test of halogens are also absent. Here only extra element nitrogen is present. Okay. So it is a Persian blue PPT. So now next we are moving towards our functional group detection. For this take pinch of compound in our test tube. So take pinch of compound in our test tube. In it add 2 ml of sodium hydroxide solution. So this is our sodium hydroxide solution and we are adding it.
Okay.
Here is a pungent smell of ammonia, and now we are going to test with a red litmus over the mouth of this test tube and see here that red litmus is converting into blue litmus. Okay, so white PPT and red litmus converting into blue litmus. So this infers that amide group is present in our organic compound. So up till now, our sodium flame has confirmed the aromatic ring, an extra element as nitrogen is present, and as a functional group, our amide group is confirmed. Okay? So from all these observations, we can conclude that here benzamide may be present. So now we proceed towards the confirmatory test of benzamide. For the confirmatory test, take 5.5 grams, that is the pinch of our substance. Okay. In it, add 5 ml of sodium hydroxide solution. So this 7 number bottle in our lab is of the, sodium hydroxide solution. So here add sodium hydroxide solution. Then we have to boil it and cool it. Okay. So we are going to boil it. So here they are observing a white PPT. Okay. So chemistry is very beautiful, full of colors. Sometimes white, sometimes yellow, sometimes green. Okay. So here a prominent white PPT is observed. And now when we test it with a red litmus, here we see what will happen. So just we keep it on the mouth of this test tube. So red litmus is converting into blue litmus. This confirms the presence of benzamide in our compound. Okay. So our unknown organic compound is benzamide. Now we are going to do a special test of benzamide. For this special test, take pinch of our compound. So this is our compound. Here add 1 ml of aniline. This is aniline. So with the help of this measuring cylinder, I am going to add this 1 ml of aniline. Then we have to heat it and see here what will happen. So here we have heated it. Yes, typical pungent smell of ammonia here, and this again confirms the presence of benzamide in our organic. So after the confirmation of our organic compound, that is the benzamide, and we have taken out its melting point, and melting point was found to be 128 degrees centigrade, which further confirms the benzamide. Okay. Now we are moving toward its derivative preparation. So the derivative of benzamide is benzoic acid. For the preparation of benzoic acid, take 1 spatula of our organic compound. So 1 spatula of compound we have taken in test tube. Then it add 10 ml of sodium hydroxide solution. So here with the help of this measuring cylinder, we have to take 10 ml of this NaOH solution. So I am adding here NaOH, and then we have to boil it. So I am going to boil it. So while boiling, we have to take strict precautions. Okay. Now here after boiling, we have to add here dilute HCl solution. Okay. So here it is our dilute HCl solution. Okay. So we have boiled it, and I am going to add here dilute. So here the presence of our white PPT, that is a white PPT is formed, and our derivative is formed here, that is the benzoic acid. Okay. So benzoic acid we have prepared, that is the derivative of benzamide. Now we are going to take the melting point of this benzoic acid, and after the melting point determination, it is found to be 122 degrees centigrade. So this was all about our today's practical, that is identification of our given organic compound. So we have successfully determined that it is our benzamide.